This is the teacher summary for Lesson 2D, quad areas. You're taking a look at your reference card towards the bottom. We're going to do areas of basic shapes. Many of these you've done before. Key things when you're working with areas. Always, equations have two sides with an equal sign. So if I ask you for the area of a rectangle, and the area of the rectangle is length times width, if I ask you to write that, you do not just write, oh, the area of the rectangle is length times width. What I want to see is this, area equals length times width. Equations, two sides with a equal sign. Always write both sides. Area of a square technically is also length times width, but we have a special circumstance. The length and the width are exactly the same thing, so all we do is we just say one side is squared. So side squared. Area of a parallelogram. You have your base. Remember, height always makes a right angle, so that is the height. This green is not the height. So area of a parallelogram is going to be the length of the base times height, which is a right angle. Area of a trapezoid. We have actually two bases here. We have one base here and another base here. There's several ways to write this. Remember, we learned that a trapezoid is basically half a parallelogram with two bases. All right, base number 1, base number 2. So the area of the trapezoid in a textbook, you're going to see this, is 1/2 times the height. Height, again, goes straight down and makes a right angle. Parentheses, base 1 plus base 2. Area of a trapezoid is 1/2 the height, base 1, plus base 2, not times. Another way to say it, which is my preference, area of a trapezoid equals the average of the bases times the height. Average of the bases times the height. Let me show you what that looks like numerically. So I would just write the word area again of a trapezoid. Now to average the bases, we add the one base plus the other base, and we divide by 2. That's average because you add and divide by 2. There's 2 units times the height. Memorize whatever equation makes the most sense to you. Area of a triangle is basically half a parallelogram. So here you have parallelogram, base times the height, and it's half of it over 2. Now that's the basic equation for all triangles. However, there's a couple nuances here. When you have an acute triangle, your height is inside. When you have a right triangle, the height is on the edge of the triangle itself. Again, look at the right angle. In an obtuse triangle, the height is technically outside. So the position of the height changes depending on the type of the triangle. This would be considered your base. That would be your base. And then only from there to there is considered your base. So our equation for area of a triangle, area equals base times the height over 2. Area of a right triangle, area equals base times the height over 2. One little change here. In a right triangle, the two sides that are connected to the right angle have a special name. They're actually called legs. So another way to express area of a right triangle, and this only works for a right triangle, is you simply take one leg times the other leg over 2. And again, the legs are the sides connected to the right angle. In an obtuse triangle, we have base times the height over 2 again. But remember, the height in an obtuse triangle is actually outside the triangle. With this information, go ahead and go to today's example, which is right here. It says, below is the diagram of a bedroom in which carpet is to be laid. The shaded area represents the carpet. We want to find the area of the carpet. Well, it's a little tricky because it's not just a rectangle. It's not just any singular shape. It's a composite shape. So first we want to determine what shapes that we actually have here. There's a couple ways we could break this down. One way is to see that we have a rectangle. Then you could also say right here, that would be another rectangle. And then here we would have a triangle. That's one way to look at it. So then you find the area of the 3 different pieces, which I'm going to go ahead and do now, and then I'll show you a shortcut. So let's do this area first of the rectangle. So I'm just going to write area of the rectangle, and you write out your equation, which is length times width. And this one's easy. Our length is right here, length, circle plug chug, times width, 10. So our area here, 3 times 1, 2 zeros, is 300 feet squared. Now the area of this rectangle, of the purple rectangle, also is length times width. But the problem is you don't have either the length or the width here, so we have to do a little deducing here. You can take your fingers and pinch them here. So take a note here. Put your 2 fingers there. That's 25, right? And then come over here, pinch. That's 10. So the question is, if from there to there is 25, and from here to here is 10, how could you find that distance? You should be able to notice it's going to be 25 minus 10, which is going to be 15 feet. So area of the rectangle, our length is 15. Our width, we still don't know, but we have it right here. It's going to be 8. So we have 8. So we do 15 times 8. Do that in the margin. You should not touch a calculator for single-digit multiplication. I prefer you to do that by hand. 8 times 5 is 40, so we carry the 4. 8 times 1 plus 4 is 12. So we have 120 feet squared. And then we have the area of a triangle, which is 1/2 base times height. But it's a special kind of triangle. We see it's a right triangle, so I'm going to use this equation, which is 1/2 leg times leg. So 1 leg here we already have is 15. So I'm going to go 15 times, and in this bracket right here we don't have it, but let's look at what we do have. From here to here, from this point to this point is going to be 12 plus 8, which is 20. So to find this, we simply go 20 minus the 30, and we get this portion right there, which of course is 10. So that's our other leg. So the area, and then that's over 2. So 15 times 10 is 150 over 2. And so the area of our triangle is going to be 75 feet squared. And then you just add all three up, and then I'm going to show you a shortcut. So we have 300 feet squared plus 120 feet squared plus 75 feet squared. That's 5. That's 9. We have 495 feet squared in our room here. That's if you break it up into 3 different shapes. But there is a bit of a trick here. Let me show you what the trick is. If you're really good at spotting the shapes, take a look at what we have here. So let's go back to the original one, which is easy, which is our rectangle, and we already figured that out. And that is area of a rectangle is length times width, 30 times 10, so that area again is 300 feet squared. We've already done that. Now this other shape, if you look very carefully, you think it looks like a rectangle and a triangle, but take a look. We have 2 parallel bases, 1, 2. This is actually a trapezoid. This is actually a trapezoid. Here's our base 1, and here's our base 2. So now we broke it down to one shape. So write your area of a trapezoid equation, which is the average of the bases. So base 1 plus base 2 over 2 times your height. And now we just work up here. So our base 1 is going to go from here to here. And we see that's going to be 12 minus 30. So we can see our base 1 is 12 minus 30. That's going to be 18 feet. So I have 18 plus my other base, which I already have, is 8 over 2 times our height. Now it's a little tricky here because height means to make a right angle, but we have a right angle right here, so our height is that black. And we did that earlier over here. This distance is 25. I'm going to bring it down here where you can see it. That's 25. But from here to here is 10. So to get our height, we just take 25 and we take away the 10, and we see that our height is going to be 15 feet. So now we work this out, and we have 8 plus 18 is going to be 26 divided by 2 times 15. That ends up being 13 times 15. And you get 195. And then we add 300 plus 195. And we get 495 feet squared. Notice you get the exact same thing. 2 different ways of attacking it. So you need to be really good at spotting your composite shapes.